From the Library of Congress in Washington, D.C.
Hi, everybody. Thanks everybody for joining us. I'm excited to have Porter Olsen here from the Maryland Institute for Technology and the Humanities. And I'll give just a brief little background on him, and then he'll tell us about the BitCurator Project, which I think a lot of people here are excited to hear more about. So Porter is in the PhD program at the University of Maryland in English. He's working with Matthew Kirschenbaum, who I think a lot of people here are familiar with. And for the last year, he's been working on the BitCurator project, which is, if I remember right, it's Myth and UNC, right? So Callie's folks in the library program there, and then the Maryland Institute for Technology and the Humanities. And I won't take up any more time by doing more introduction, but I'll just mention that the Talking About Digital Archives group is going to have a lunch conversation with Porter after this. So if you want to grab food in the cafeteria and join us in the little room on the side of the cafeteria, you're welcome. And I'll turn it over.
Thanks, Trevor. When Trevor invited me to come do this, he was like, "Oh, just come demo for some friends at Library of Congress." And I walked in here and I saw those cameras and I was like, what did I sign up for?
That's Trevor.
Yeah. So I assume you are all friends. So as Trevor said, so I'm with Myth, a GA at Myth, and I've been working with them since they brought me on to work with the BitCurator project. And before going back to school to get my PhD in English, I worked for a Linux development company. And so I had a background working with Linux and technology before I decided to go be an English nerd. And that was a really good fit, and I convinced them to give me a job. So when I came up with the title, I was kind of, I don't know, I didn't spend a lot of time on it. So as I thought about it, I came up with a better title. So Professor Plum in the library with the toolbox, digital forensics and born digital curation with BitCurator. So do you guys get library gags all the time? Is this like really common? Sorry. My information, you can follow me on Twitter. It's PW Olsen, and if you have questions, you can email me at polsen@umd.edu. But I do want to talk about digital forensics, which does, obviously kind of tie into this idea of kind of emerging out of criminal justice and what's being done in that realm, and how we can repurpose those tools that are being developed to be useful for libraries, museums, and archives, you people. So what I'm going to do in this demo is I'm going to try to do a lot of this in live demo, but if things don't work, I have slides instead. But I'm going to introduce you to how we envision people using the virtual BitCurator, ideally perhaps as a virtual machine embedded within a Windows operating system. We'll talk more about that. We're going to talk about exporting file system metadata and FIWOC, which is one of these digital curation or digital forensics tools. Locating, and this is I think one of the more important things, is locating and identifying personal identifiable information. The tool we're going to talk about is bulk extractor. Doing some automated repetitive tasks using Nautilus scripts. And then something that's, I think, probably our biggest contribution as far as kind of code and production is generating tool reports that will allow you to both see human-readable reports on what's being found when those digital forensics tools go through and find information by analyzing the disk images. So a little bit about BitCurator. As I've said, what we're really interested in is taking these digital forensics tools and repurposing them for the libraries. And we want to do that by specifically incorporating what you do as archivists and librarians. And so we spend a lot of time working with our, if you look at the two groups here at the bottom here, two groups that we've assembled as advisors, the Professional Experts Panel and the Development Advisory Groups. Both groups of individuals have experience working with either development or actually working in the field, working with digital curation in one way or the other. And we really want to make sure that one thing that's really important to us is what we produce becomes useful and that it actually gets into the hands of people and gets used. Incidentally, I should mention maybe that we're a Mellon-funded project, and we had funding for our first year, and then we applied for a second year round of funding, and we just got word that we've been awarded that, so we're really excited about that. So, and a big focus for what we're going to do in the second year will be outreach to practitioners and getting BitCurator, both refining it as a product and making sure it gets into the hands of people who can use it. I'll just take a minute to recognize Leslie, who is, I'm sure you all know, who's a member of our Professional Experts Panel. We had her over at Myth last year. We picked her brain along with the rest of the panel about just how people do, what kind of workflows they use as they approach digital, born digital materials. And we've tried to think carefully about that as we produce the tools that we're using. So as I mentioned, we're a Mellon-funded project. The team, the PI is Cal Lee, with the co-PI is Matt Kirschenbaum. Cam Woods is our technical lead. And then Alex is the project manager at UNC, along with Sunita Misra, and then lowly me, the last on the list. I'm a GA at Myth. I primarily worked with documentation and testing so far. I've kind of already talked about this, workflows. We also are very interested in how we then make, once we are able to collect the digital, the information, how we can make that information and born digital material available to the public. And that's kind of that, it's the, I think, the last mile of digital curation. Do I need to explain that? Everybody, sorry. When the internet first came out, the biggest problem was the last mile. They had all this infrastructure built out, but actually getting from the last kind of junction to your house was the hardest problem that they had to face until they ran all the fiber optic lines. And so I think we're in that space right now where we've got a lot of tools that we can kind of collect this information, but then how do we take that and make it available to researchers? And that's one of the challenges I think we're going to try to work with. So does this look familiar to anybody? So this is a problem. You guys are really good at taking paper, right, and doing stuff with it. But there tends to be, I think, widely a challenge when we're faced with things like this, hard drives, floppy drives. I kid you not, I had a guy come into Myth just last week asking if I could read data off his 8-inch floppy disks. I really wanted to. I couldn't. I got a whole bunch of data off some accompanying 5¼ inch disks, which was really cool. But so far, we don't have a way of reading that material. So what do we do with this data? How do we not only get the data off of it, but how do we preserve that data in such a way that we know that important things like provenance and where and the continuity of that information is retained? That's why we feel the BitCurator project can intervene here to bring these digital forensics tools to the way that we collect this kind of material. By forensics, for those who aren't familiar with the term, it really means just that it's legally admissible. So when we talk about digital forensics, what we're talking about is creating or going to a computer and creating a body of evidence that is so exact, right, so meticulous, that it can actually be used in a court of law, right? And so we kind of want to embrace that rigor in the way that we approach the curation of born digital materials. Okay, so really I envision a lot of this just as a demo. So that's kind of the big picture. And really I just want to now show you what we've been doing. And so I have a lot of slides that show this stuff, but for the most part I'm just going to show instead of tell. So you can run the BitCurator environment in one of two ways. So first of all, let me back up and just say that when we talk about BitCurator, we're really talking about a collection of tools that we've embedded into a customized version of Linux. And so that's why we refer to it as the BitCurator Environment. All of these tools that are individually being produced by the digital forensics community, we bring them into a Linux environment, package that Linux operating system, and then make it available for you. So if you were to go to our wiki page, which is just wiki.bitcurator.net, you'll see, if you scroll down to downloads, you'll see two downloads. The first is for a virtual machine, a prepackaged virtual machine, and the second is for an ISO. Who here has ever installed an operating system before? Okay, great. So the typical way that you install an operating system is you download an ISO, this is for Linux, and you burn it onto a disk, you insert the disk into the drive, and then you follow the instructions as it takes you through the installation process. That works exactly the way we have things set up. If you were to download the ISO, that works exactly like it would with any other version of Linux. Windows follows in roughly the same process. Alternatively, and that is actually how we kind of envision the best practices way of doing it, installing it as the primary operating system on a dedicated machine. But we also recognize that might be problematic depending on resources. Not only that, just by virtue of limitations, there are tools that you will likely be using that you've paid money for and you want to continue using that are Windows-based or OS X-based. And so as an alternative to just the fully regular install of Linux, we've also put together a virtual machine. Has anybody worked with a virtual machine before? Okay, great. So what a virtual machine does is it creates effectively an install of an operating system embedded within a host operating system. So if you can imagine Windows as your regular operating system, you're doing what you're doing. You install an application like VirtualBox or VMware, and then you can install you install into that application another operating system that looks, feels like you're in that different, what we call a guest operating system. This might become clearer as I show you what we do with BitCurator. So you would download either BitCurator, the virtual machine, or the operating system. And over here, we're putting together a number of screencasts. And so if you're not sick of my voice by the end of this, you can click here when you do the download if you guys want to do this, and it'll take you through the installation process for setting up a virtual machine. I don't know how I got the lucky draw to. Actually, I do know. It has to do with where I fall on that list we saw earlier. So what you do, so you download, I'm just going to take you through that really quick. So you would click here to download the virtual machine. It takes an entire operating system and it compresses it down as tightly as we can. So it's a big download, 2.5 gigs or so, but it's still really, really well compressed. You would extract it. In Windows, you're going to need an additional tool, either something called WinRAR, or there's also a tool called 7-zip. Both are explained in the video to extract the files. And once you extract the files, they'll show up in, you'll of course extract them to whatever directory you care to. So you'll extract the files. They extract to over 6 gigabytes, and they exist on your hard drive. Once those files are extracted, you need to install an application called VirtualBox. Now, VirtualBox is it's a free and open source application, a virtual machine application that's made available by Oracle. You can pick it up from virtualbox.org. And it will allow you to embed that operating system into your host operating system. So you have this platform layer of VirtualBox that then the Linux environment will sit on top of. Once you've downloaded and extracted the virtual machine, you need to add it to VirtualBox. You need to tell VirtualBox where it is, and that's you just click Machine, click Add, navigate to where you extract the files, click it, and then it adds it. So I just have this one here that wasn't there before. I don't know if you noticed that. So this is now added. And if I were to double click on that, it would take me right into the operating system. Instead, we're a version newer, so we're going to look at version 2.2. So, has anybody used Ubuntu Linux? Okay, so a lot of the same hands are going up. That's great. So, if you've ever used Ubuntu Linux, this should look really familiar. This is Ubuntu Linux, and without getting kind of too into the weeds, it's basically, so again, that idea of layers, right? It's that Linux layer that's sitting on top of the virtual machine layer that then is sitting on top of your regular OS. I can do anything that I can do in Linux in this environment. Very specifically, it gives me a place to take these digital forensics tools that are being developed for Linux environments and put them into practice regardless of the host operating system that I'm running. I can run this as a virtual environment in another Linux environment, I can run it in Windows, and I can run it in Mac OS X. So regardless of whatever else you're doing, you have the opportunity to use these tools in conjunction with the other applications you might need. So we've got this virtual machine up and running. What can we do with it? Well, I'm going to take you through, and this is, we're going to appeal to the demo gods, as I mentioned last night. I'm going to walk you through some of the capabilities that we have in BitCurator. So I just put in a CD, and I want to show you the content before I jump into BitCurator. So one of the challenges with working with virtual machines is that you have to give permissions for the host you have to give permissions for the guest to get access to the media devices. So as you connect media devices to the virtual machine, passing them through from the host to the virtual machine is definitely one of the existing challenges. Okay. So I've just put on here just some BitCurator stuff that I've worked on in the past, some of my son's pictures, and then this zip file called other stuff. And in this file, I have stuff I don't want you to see. So I've got a social security number, not my real social security number, and a credit card number, not a real credit card number. And essentially, what I want to show you is how, when we talk about that personal identifiable information analysis, how this information gets found. And I want to also emphasize the fact that it is that file is located in a compressed file. It's in a zip file. It's not just in the regular file. Okay, so if we come back over here, and with any luck, this will pick back up. Okay. So one of the main you may be familiar with the term respect the fonds, right? This is a term that's used to ward against contamination of any kinds of forensics evidence, right? And in digital forensics, what that means is you have to be very careful anytime you start using a media device, whether or not that when you interact with it, you actually write something back to that device. So this is important for floppy disks, jump drives, hard drives. Obviously not so much with a CD-ROM disk, right? But I'll show you. So there are a couple of layers of protection that you can use. There are hardware solutions. So if anybody's worked with a Fred machine, then you know that there are kind of built-in tools that are what we call a write blocker. You can get individual write blockers, little machines that you plug your media into before you plug it into your computer. But you can also do some protections via software. And so one of the features that we've added to the BitCurator environment is a safe mounting script. And what this does is it shows all the media devices. So we have my hard drive here, and then we have the CD that I had here. And this will mount it for us read-only. Now, obviously, with a CD, it's not that important, but with a jump drive, it would be very important, right? If you plug in a jump drive and you mount it, you want to mount it such that the operating system isn't going to write any data back to that jump drive. So, let's double check. And there's our CD, again, mounted read-only. Okay, so what I want to do then is, the first tool that we use is something called Geimager. And this is an imaging tool. And what it does is it creates that forensics disk image that I was talking about. There is a debate, and I welcome your comments. Incidentally, this doesn't have to be just me talking. If people have thoughts or questions, please do ask. But there's a pretty robust debate over what do we do with digital, born digital materials. Do we just copy the files off onto another bigger hard drive, or do we pursue something more rigorous like creating disk images? Obviously, with the BitCurator team, we feel pretty strongly about the importance of creating disk images. And there are a couple of reasons that I'll mention for that. The first is, one thing, we're really interested in preserving the metadata that surrounds all these files. And when you move from one file system to another, you lose that metadata. So for example, if you had some floppy disks that were formatted like FAT16, and you wanted to copy that data onto an NTFS file system. So that would be, say, 3.5 inch floppy disk from back in the day to your standard Windows 7 hard drive formatted for today. You would lose all of that metadata, when the file was created, when it was last modified, space on the hard drive or on the floppy disk. You would lose all that metadata when you transfer over to that other file system. So that's one of the reasons that we feel it's important. The other is transportability. And this actually speaks to working with the original media. As I mentioned before, I wanted to get that data off that 8-inch floppy disk, but that was just impossible, right? That hardware is available, but it's increasingly rare. It breaks down, and nobody has parts to replace it. There's going to be a point where we won't be able to access that original media anymore, but disk images of that media will continue to be accessible, so long as there are tools to be able to access those file systems. There's obviously a level of complexity that comes with this, and I think that's one of the main arguments against doing disk images, but that's something that people just have to work out for themselves. So to create a disk image with BitCurator, we've got that disk in the drive, we've mounted it read-only, and now we want to create that image. We would just right-click on the image. Just quickly, I do think one of the challenges to BitCurator is that you do have to start to adopt some Linux parlance if you're not familiar with Linux. So how things are mounted, even the term mounted. When I say mounted, and I'm talking about hard drives and disks, who knows what I'm talking about? See, and you shouldn't feel bad if you don't, right? That's part of the problem. When you plug your jump drive into Windows, right, and before it wasn't there at all, but you plug it in and now it is there, that's just Windows, and the term we use for that in computer world is is mounting the disk, right? And so in a Linux environment, it kind of meticulously mounts everything. It mounts the floppy disk, the hard drives, the CD-ROM drive, and it takes that data and it says, this data is located here, and it creates just a pointer. It says whenever you want to actually access that hard drive, look here, and then that pointer links it back to that data. Understanding some of this parlance, I think, is one of the challenges that BitCurator and some of these tools face. So, as I was saying, the device is dev SR0. That's that mount point. That's that pointer that says go look here to find that information. So, if I click on acquire image, this is something that I think could be really useful. We're working on something called the Born Digital Working Group at the University of Maryland, where it's a collaborative effort with the library there and special collections. And we're interested in, again, this idea of taking these tools that are developed specifically with prosecutorial, I don't know, intent in mind, right? So, taking this to a court, and then making them work with what people want to do with born digital material, with curation of born digital materials. And so you see something like case number, evidence number, examiner. All of these fields kind of point to the idea that this is actually going to be something for for a court. These fields, however, are just fields, and we can use them however we want. So one thing that we're thinking about is how can we kind of repurpose these fields, pull out this metadata, and then apply it to things like accession numbers and useful information that might be more in the wheelhouse of archivists. So I would just put in like my name, and so forth. Select the directory I want to extract it to. And then give it a name. Yeah?
I was just curious about the file formats at the top, the different kinds of disk images.
Okay, good. So your most basic disk image is what's called a raw or DD image, and that just stands for disk dump, and it's been with us for a very long time. And it basically just reads bit 1, bit 2, bit 3, bit 4 right off that disk, and then dumps it and creates an image of it. And so when I'm talking about image, what I'm talking about is I have that CD that you saw, that physical media CD, right? And I'm going to create a bit-for-bit copy. Every single bit that is on that CD, I'm going to create a file that has exact matching for each of those different bits. But it's going to exist as a file on my hard drive instead of as that CD. So that's the raw disk image. We'll do that bit for bit, just copy. And then the digital forensics community have come up with a couple of other alternative types of images. The first one is expert witness format, and then advanced forensics images or AFF images. There's something of a competition between the two about which is the better option. But in both cases, the way they differ from DD is they include an additional level of metadata about the disk image along with the disk image. So it actually takes that metadata and embeds it into the image itself so that that metadata always travels with the disk image.
How would those images relate to something like an ISO image, which I understand is a different operating system? But
Sure. It ends up being a very similar idea, right? So if you've worked with an ISO image, right, you can take that ISO image and you can burn it. So if we're talking about a CD, right, you create an ISO image of whatever it is, and you can burn that image onto multiple CDs, and they all look exactly the same, right? So the ISO image is conceptually is very, very similar, but it doesn't have kind of that meticulous bit for bit kind of level that we're interested in.
Two questions. Does expert witness or AFF offer any space efficiencies?
Not really, because you're going to be limited by the media itself. And you don't necessarily want to compress the image. You really want to kind of have it as exactly as it appears. I think that there you can do compression after the fact, but the image itself, it just wants to be meticulous about, every bit equals every bit.
Second question is, if you do enter additional metadata, where is that stored with the Linux disk image?
With the Linux, oh, okay, good question. So notice what happens when I select Linux disk image. All of those fields gray out. So it was never designed to do this kind of work, right? That's not what it was about. Good. Any other questions? Yeah.
Are you finding challenges with geospatial data and with social media?
So the challenge that presents is that we don't get it in the form of disks usually, right? So that is one of the things that BitCurator as a project really isn't that helpful for yet, but we anticipate that down the road it will be, because that geospatial data or your Facebook page exists on a hard drive somewhere, right? And there may be a point where that needs to be preserved in some sort of meaningful way, and at that point the tools that BitCurator is interested in developing would come into play. A lot of the attention that we've gotten so far really has been, and you guys know this from your own practice, right? What are you working with right now? You're working with floppy disks and CDs, right? And so a lot of the interest that we've gotten has been around, I have this file, and the contributor put in a whole bunch of extra floppy disks, and they've been sitting there for 20 years. I don't know what to do with them. Can you help me, right? But I think that's a good question, and that's where we get to eventually. Yeah.
I mean, I connect the dots with the ISO disk image question. There are certain kinds of content where logical representation of files, which might be the case for geospatial, is the goal, and then there's another time when forensics is the goal. And in the ISO camp, when you're dealing with CD-ROMs or with geospatial data, you might be in the logical game rather than the forensic game.
I completely agree, and I'm as invested as I am in BitCurator and what we're doing. I think it would be an absolute mistake to assume that the only way to do anything is creating forensics disk images, because I do think that you have to look at your own practices, your own needs, and I've talked to a number of people in the community. A lot of people working in government, actually, they never see anything other than the logical image or the logical data, right? Somebody emails them the folder, a zipped, compressed folder of medical records or whatever it is that they have to hold. So I think that it has to work on a case-by-case basis. Yeah.
So in order to image a floppy or a hard drive, does the operating system need to understand the file system of the floppy or hard drive, or can you image without being able to make sense of the underlying file system?
You have to be able to. So we're kind of in the realm of software, but there's another component to this, and that's the hardware. How do I get that 5 1/4 inch data off that floppy disk into a contemporary computer? And so that piece you have to have customized hardware, not necessarily custom, but it's not that daunting, really. You have to have a way of connecting that data from the floppy disk drive to your computer. There are a number of solutions that people do this. Well, the one that I recommend and have worked with is something called the FC5025, which is specifically designed to pull data off of that 5 1/4 inch floppy, and then so it's just a little circuit board, has a plug for the USB, or for the USB that would go into your contemporary computer, and then a cable for a 5 1/4 inch floppy. And so that circuit board does kind of all that translation. So there's software and hardware that recognizes the different file systems of the different disks that you might put into that 5 1/4 inch disk, and then there's software on your machine that can then recognize when those different disks are installed. But yeah, for all of those cases, you have to have a way of reading that. So I mentioned before that I had a guy who had some data that he had found, like in the basement of somebody he really, that he really wanted to get, and he had this file folder, and he had 5 1/4 inch and 8 inch floppies, and because I had that set up, I could get that data off the 5 1/4 inch floppies, but I couldn't do anything with the 8 inch. It would require another solution.
So what was that tool called again?
It's the FC5025 by Access Data.
We're ordering a couple for the ones that we'll have to do that.
So if I understand, if you had a Mac formatted floppy, but you had a Windows machine, if you had this device, it would understand the Mac formatting and allow you to interact with that.
That's exactly right. Yep. I wrote a blog post about a machine that we built at Myth, and I can send that URL to Trevor, and if you guys are interested, you can check out kind of what we've done there. Because that is the other side of this coin, and it's as big a challenge as the software side of things. Good. Okay, so if I were going to go ahead and make this image, create this image, then I would hit the OK button. I've already actually done it. It takes a few minutes, so we won't jump into that right now. So it would create the image, and then in our testing, created a testing directory. So this backup CD EO1 is the expert witness format image that I've made, and just again to emphasize, so this is a bit-for-bit copy. This is the equivalent of that CD. This file is the equivalent of that CD that I put into my drive. There's some additional metadata available here.
Actually, I have a question.
Yeah.
What about bad sectors on the media?
Okay.
Copy those over?
It does. So it's again a bit-for-bit copy. So it actually doesn't care about bad sectors. That doesn't mean that what you get on the other side of it will necessarily work, right? But it doesn't matter. It'll recognize it as a bad sector. So we've created this disk image, and we've got an image, and we've now protected that data and that content. Now what do we do with it? Well, this is where the digital forensics tools actually come in. So let me start with bulk extractor, because I think this will give us a chance to see some of the So what bulk extractor does is it goes and it reads that disk image, and again, and it just reads the bit stream. It's not reading the file system, so it actually doesn't care what the file system is. It just reads the bit stream, and then it pulls out a variety of information about it. And what bulk extractor does is it has what it calls scanners, and these scanners look for certain things like account information. That's why I showed you the file before we started. Emails, URLs, a number of different things that are of interest primarily to people working in criminal justice, right? So there is kind of a limitation here in that what they're interested in isn't necessarily what we're interested in. In fact, it's kind of the opposite. What they're doing is they're looking for things to expose, right, to shows like somebody did something wrong, whereas we're kind of looking for things to kind of pull back so that ideally we can, in kind of the full length, what we do with this, we make that disk image available to somebody, to a researcher, right, where we wouldn't allow them to actually access the physical media, but we do so first by redacting certain personal identifiable information. And this gets to that second part where I talked about that we're really interested in, which is that access. What can you do when you've gone through and redacted all of this personal identifiable information that you couldn't do, i.e. making it publicly available on the web, where you couldn't do if you just had the full information. So it scans the disk image, and then it looks for these different scan through these different scanners for what it calls features. And a feature is just going to be any instance of an account or a web page and so forth. So I would input the information here, and what it does is actually makes it creates a number of files. So you actually dump it out to a directory as opposed to a single file. I won't go through that process here, but I've already run my backup CD. And if we see here, we have CCN for accounts text. And there's the fake social security number that I showed you. So I think this is cool for a couple of reasons. First of all, it found the social security number. Second of all, as I mentioned, it found it by digging into that zipped folder. And this comes back to the idea that it's not actually looking at the file system, it's looking at that bit stream. So it's not limited in some ways, yeah.
Was your zip compressed or uncompressed?
The zip, it was compressed. Yeah.
Okay.
Is that?
I mean, but then it would have to, in order to find that, it would have to decompress it.
It has to.
Just like things in PDF are flat encoded.
Uh-huh.
So the words aren't there, but there's an encoding of the words.
Yeah, right. So it does actually, it has a number of logics that it uses as it processes its data. For example, notice that the credit card number was not found. That actually isn't an error. What it does is it checks, so your credit card number is algorithmically produced, and there's an algorithm that you can check a credit card number against to make sure that it's a legit credit card number. And because I made up that credit card number, it's just a string of random numbers. It checked that credit card number, said this is just numbers. It actually it's not a credit card number at all. Incidentally, the reason that it found this social security number is because I added the letters SSN next to it. As you can imagine, a string of 9 numbers on any disk image that you can imagine is going to be infinitely common. So it's actually not necessarily it's looking for 9 numbers plus social, so plus SSN, plus security, right? It's looking for those things around it that would identify it as a social security number. So there's other things like domains, where people went on the internet, email addresses, and a variety of other information that somebody might want redacted from their disk image before it was made public. You can also include regular expressions. So if there's not a scanner that hits the thing that you're looking for, you can add a regular expression, and you can customize saying, look look for this word or look for this string of words, and you can actually create a batch file. So you can call the file instead of typing it out every time, so that it always kind of looks through those. But that's great, but how useful is this really? This gets us to the next part where we want to make this information available. How are we doing on time? Okay. Actually, I skipped one point. In addition to bulk extractor, we have another tool called FiWalk. And FiWalk, what it does is anyway, I won't show you the command line. It's boring anyway. What FiWalk does is it reads the file system and it parses it out in what's called DFXML. And just like the name would suggest, it's Digital Forensics XML. And what that ends up looking like is this. So this is every file on the image and a variety of metadata collected about it. And so if you're in the digital forensics community, this is really useful to you, but it is still kind of useless just as a file, right? Just as the information that you see here. So what we're trying to do with BitCurator is take both of the tools like bulk extractor and FiWalk and bring them together and to produce them into something that you could actually use. And that leads us to our reporting. And like I said, I think this is where kind of like we're really contributing to the community with what we've got here. So I don't know how well you can see that. So this is a PDF. So we run a number of Python scripts that obviously I'm not going to run through with you right now. But we've got that disk image. We've generated this information both by running it through bulk extractor and through FiWalk. And then we have a number of Python scripts that take that information and put it into usable, human-readable, and machine-readable formats. So here you have a list of all, I mentioned the term features. These are the different features that, which is just anything like a account number or a URL, that bulk extractor has found, the position on the disk, and the file name. File name, obviously, it's not picking up as well in this report as it might otherwise, but the idea is, one of the challenges is that when it reads across the files, the image, it knows where a feature is based on its offset in the image. So if you imagine bit 1 through bit 1 billion or whatever it is at the end of that image, it knows where the feature is as the number of bits offset in that image. And that doesn't do you very much good unless you're really good at counting. And so what we're trying to do is we're trying to match that feature with the file name, right? So that you could go into the image, find the file, redact it, or whatever you need to do. And then we have here telephone number. That's not beautiful. So here we have our Social Security number again. Printed out into a report. And so this is the report on all of the account information. So if there were other account information in that file or in that image, it would show up here and you would know where it was. We've also just implemented being able to create data using and outputting it to spreadsheets. So it will output the file name, the extension, file size. In other reports, it's actually been able to pick up the last time it was changed, last time it was accessed. Not sure exactly why those aren't coming through right now, but we're in alpha, so hopefully you'll forgive me. And also very useful, it will automatically generate MD5 and other hashes of the file. So this is for every file in the entire disk image. So this is a good way to automate the collection of that file level information and then hold on to it in any kind of repository that you're using. The last thing that I'll show you guys is some of the custom work that we've done with Nautilus scripts. Nautilus is the file browser of Linux, and this is actually kind of quick. Nautilus it can be extended much like you get add-ons into your browser. The Nautilus file browser can be extended through customized scripts, and the digital forensics community have actually come up with a number of useful scripts for doing things at the file level and analyzing a file. So for example, if you go here, you right-click on the file and go to Scripts, and you click File Info, you can get a variety of information about that, including kind of what it is, metadata, the different hash values, and so forth. So you can do a variety of things through Nautilus, through these custom scripts. Including finding files, using the safe mount feature, generating MD5s, and viewing the file in hex editor. So that is the state of the BitCurator environment. Obviously, we are still in development. I would like to encourage you all to visit our wiki. and download the image. One of the other good things about working with a virtual machine is that if you delete it, it's gone. There's like no, it's just taking up some space on your hard drive, and then when it's gone, so you can just do whatever you want with it. And also, if you screw it up completely, it doesn't matter. You just delete it and download another one, and you're back where you were before. So you can download and install it here. And I would also encourage you to join our Google groups. We announce things like newer versions of the virtual machine and BitCurator there. And then if you have any questions, we'd love to help you out. I mentioned before that one of our primary goals is outreach over this coming year. And so we'll do our best. We're on Twitter. And here we really are interested in people who might be interested in using BitCurator and helping you guys implement it in your workflows. Thank you. Do we have time for questions? Okay. Yeah.
Is there a process for updating BitCurator other than just launching a new VM?
Not right now. It's comprised of so many different parts that I'm not sure if that's going to really be possible. So maybe bulk extractor gets an update, but the others don't, right? And so, we do have a GitHub repository, so you could just like pull down just the bulk extractor piece if that was the case. But I think as far as kind of official releases, we'll release it as new machines. Other questions?
If you download the virtual machine on a laptop, for example, can you do forensics on the laptop itself, or does it have to be on tangible?
No, because you need access to that. Really, we're working at the level of the disk image. Some of these tools have the capacity to work off raw media, but they're really not at their best at that.
So if you imaged your hard drive, then you could then...
Yeah, create an image of your hard drive first, then bring it in. Yeah.
On a second drive.
Right, yeah.
It would be a meta analysis.
Just recursively.
Yeah, just sit there and analyze. Yeah. Good. Yeah.
Do you guys run this on top of the Fred?
No, but we just got a Fred at the University of Maryland libraries, and that is something we'll probably do next week. But there's no reason it can't run on a Fred. Fred, presumes that you'll have a Linux. It'll be a multi-boot option where you'll boot either into the Windows or Linux. So there's no reason why we can't run it as a virtual machine.
I'm wondering about the hardware write blocker.
Yeah. That's a good question. Other write blockers don't have a problem, but I haven't used their particular one. And it actually probably shouldn't matter at all, because it will be blocked before it gets to, so if we're in a virtual machine, it'll be blocked before it actually gets to the Windows host operating system, and then it's just a question of passing it through to the guest, and it'll be blocked the entire time. One question is if you actually install it as the primary operating system, how will Ubuntu treat that? Can't remember the brand of their write blocker. Yeah, but so that's a question. Check with me next week. There you go. All right. Anything else? All right. Thanks.
This has been a presentation of the Library of Congress. Visit us at loc.gov.